Hey guys!
Hello!
So this week we had a request from a viewer.
We did. Yep.
Who was it?
It was the Galactus 900.
Okay.
And they built essentially this, but they had a lot of problems with noise and picking up buzz and such. So the first thing I'll say for that is, depends on, what kind of lights you've got. It may be picking up 60 hertz from like your fluorescence or from whatever lights are in the room. Or maybe you're putting it next to your computer and maybe it's picking up interference from that.
I can hear this one picking up a radio station at the moment.
Yep.
Yeah, very faintly, but it's there.
Right. So the only thing you can really do is kind of try to shorten your wires, try to get it into a place where it's not near any electrical things.
Building it on a PCB would be ideal, because then your traces are as short as possible.
Yep.
And you don't have a bunch of wires around acting as antennas.
Yep. But we were also I think he also wanted a parts list and to have a step-by-step. So I thought we would do a step-by-step and show it working. Did you want to play a little bit before we dismantled it all?
Sure. I just hooked up one of my cigar box guitars to it.
Yay.
So it's functional.
Yep. So I'm going to go ahead and take it all apart and we'll talk about the LM386 chip here. And it is an audio amplifying chip. Power gone.
I like the little
I know.
noise it makes when you unplug it.
I'll take all the wires out. Resistors. And I think at some point somebody asked me what kind or how to include volume control, and I said, oh, I don't know, but actually I do. I just wasn't thinking very hard.
We demonstrated that in our follow-up video to our original LM386 video. I actually built a little tremolo circuit on it.
I do remember that.
It showed how to change the volume.
Okay, so we have the LM386 chip, and it's an audio amplifying chip via the use and the magic of op amps, and that's all internal. So the chip here, you'll see a band, and then you'll see a little divot. That's where you know where pins 1 and 8 are. So here's pin 1, here's that divot, and then here's pin 8. And 1 and 8 are used for gain. So if you put a capacitor in between them, like 10 microfarads, then that'll increase the gain by, I think, like 20 decibels, I want to say. And then pin number 2 is for the negative input, and that usually just goes to ground. Pin number 3 goes to the positive output, which is essentially your audio signal.
So to be clear on this, this is an op amp, so basically the difference between these two is what's being amplified, right?
Correct.
Okay.
Yep. So ground goes into this one. Your audio signal goes into this one. And then ground, pin 4 just goes to ground. So 2 and 4 go to ground. And then pin 5, V out, that's where your signal comes out to Mr. Speaker here. Pin 6, VS, that I think it provides power to the chip.
Yeah.
So
you're using 9 volts.
Yep. And this chip will take anywhere from 4 to 12 volts. So I just hooked up a 9-volt battery onto the breadboard wires here, or breadboard rails here. And bypass we don't use, just because we don't really need to. And gain, again, I said before, if you stick a capacitor in between here.
Yeah, those are basically there so that you can use an external capacitor.
Yep. And on the positive input, you can put a variable resistor, which is what the your Googleable LM386 audio amp circuit will show. It'll have a variable resistor, but I chose to just use a 10K resistor instead. So, we have a list. We have the supply voltage of 412 volts, which is, again, the battery. Ooh, it's kind of hot. Is this supposed to get hot?
Well, the more current you draw through it, the warmer it gets.
Ooh, Yeah, it's quite hot. Anyway, so I'm going to go ahead and hook that up. And black is usually to ground. Red is red hot. Okay, so that's there. And then the 10K resistor, that's again going to be between pin 3 and ground. So we'll get one of those, and that's a brown, black, orange resistor. Let's see, pin 3 and ground. One, two, three. Okay. And then we have a 10 ohm resistor, and that 10 ohm resistor is going to go from the, I guess the input signal, I want to say. Let me see, where is this? V out. It's going to go between V out and ground. And I'll show you guys the schematic so you can
control your volume there. The less resistance, the more the signal is going to go to ground. The more resistance, the more the signal is going to go to your actual output.
Right. Now the reason I'm putting this so far away from the chip is because there's actually a capacitor connecting these two, connecting the pin 5 to the resistor. So
you don't want to bleed the DC down to ground. You just want to bleed the AC signal across the capacitor to ground.
Right. 0.05 capacitor. Now that is exactly the same capacitor I was just talking about, going from pin 5 to ground.
This essentially makes an RC filter.
Yep. And now this one, actually I was pretty liberal in terms of the size. It's a 0.02 microfarad capacitor, but it obviously works just as well. I actually even have a 0.005 capacitor that I was able to use with it, so it's pretty flexible.
Yeah, basically by changing the value of that capacitor, you're changing the roll-off point of that RC filter.
Yep. And then we have the 220 capacitor, which in the circuit or the schematic it says 250. Again, I was pretty liberal because we didn't have 250s, we only had 220s. And there is polarity involved in this, and just in case you don't know, so usually all these capacitors, I think these are electrolytics. Yep. They'll have this band with like a little minus sign. That's the negative side.
Yeah.
Yep, that's the negative side. So if you see a positive symbol in the schematic, then you know, well, the positive side's got to face that way. And so this positive is going to connect here
on your V out.
Yep. And then it's going to connect out here to the middle of nowhere. And actually that middle of nowhere ends up being where
your speaker
output
output
goes. Yep. And the speaker output, I'll go ahead and connect there. Okay. So one side of the speaker output goes to
your DC blocking capacitor there.
Correct. And the other side goes to ground.
Yeah. And on most audio circuits, the ground is connected along everything. So
right.
You're only ever messing with the positive side on these little things.
Right. Then the speaker, I have here, it's an 8 ohm speaker. Then let's see, the 10 microfarad capacitor is for the gain between pins 1 and 8. And again, there's that minus sign for the cathode side of the capacitor. And the positive end of this particular capacitor should go to pin 1. So I'm going to go ahead and put that to pin 1. Alright, and then as we said before, pins 2 and 4, 2 being the negative input and 4 being ground, they go to ground. So I'm going to pretty much put
your comparator or whatever.
Right. So 2.
So we're comparing 0 volts to whatever's coming through.
To ground.
And there's lots of different ways to approach this part, so
Yep.
you know, look up a few, see what works well for you.
Yep. And 4.
And that's the ground pin.
Yes. To ground. Okay. And then the last part of this, is it still hot? So then the last part of this is going to be the wires. Oh, well, those are the wires. Okay. So
You've got your input yet. But you've got some.
oh, and you know what I gotta do? I forgot about pin 7, which is to power the chip, which is why nothing's happening right now. But before I power the chip, I'm actually going to incorporate this 1/4-inch jack. So these wires are going to a tip and a sleeve of a 1/4-inch jack, and maybe we should do a video on like tip ring and sleeve. That might be nice. But it's essentially just like headed to our guitar there. So I have...
Sane people would solder these wires together, but this is Addy, so...
Yeah, that is correct. So then this one, I believe, this is the tip, and that goes to power. And then this one, or wait.
Ground is more likely.
No, power is what it says. Power, and then this one goes to, we'll try it. Let's try it. Goes to pin 3 because that's the audio signal. Okay, we'll try it. And then I'm gonna give power to pin 7, which is giving power to the chip. Woo, it's a cluster of wires. Woo! And it works.
So, yeah.
So awesome. And I'm gonna go ahead and disconnect this before the battery gets too hot. Not sure why it got hot, but either way, so just remember pin 1 and 8 can get connected by a 10 microfarad capacitor. 2 and 4 go to ground.
That sets the gain, and if you want it to be more clean and less crunchy, that should be lower or not there at all.
Right. I think we actually showed in the first video, so no biggie. But, so pins 2 to ground. Pin 3 is where the audio signal comes in on the, I want to say sleeve side. And, which is kind of strange, but whatever.
Yeah, you're only dealing with half the waveform the way that it's set up right now. Like I said, there's other ways to do this.
Right. And then a resistor to ground. Now this resistor, if you want volume control, this particular resistor can be a 10K ohm variable resistor. Okay, I chose just for because I didn't want it to be bulky, I just chose a 10K resistor straight up. Pin 4, ground, goes to ground. Pin 5 gets 2 capacitors connected to it, a 0.05 microfarad and a 220 microfarad capacitor. The 0.05 microfarad capacitor goes to a 10 ohm resistor. This one is actually 7.5. Again, it's pretty flexible. To ground. And then this 220 gets connected to the hot side of the speaker. Okay, and then the other side of the speaker gets connected to ground. And then pin 7, again to power. And 8, you got it. I think we've gone through it. So, hopefully this helps you set yours up and let us know if it works. Let us know if it doesn't work, if it's still picking stuff up. Again, think about if it's sitting next to your monitor or if it's sitting under lights, what have you, then that could be it.
Yeah. There's a lot of ways to improve this circuit. Take a look online. There's lots of different little amplifiers that use this chip. So lots of information and resources out there.
Yep.
This is probably not the best way to do it, but it's quick and easy.
But it works. Yep. So,
all right.
That's it.
That's it for us for this week. We'll see you guys next week.
Bye.
Bye.
We post videos all the time, so don't forget to subscribe and follow us on Twitter at TYMKRS.